So in this video, I'm just going to briefly show you how I conducted the repeated measures Oneway ANOVA on the Weatherall et al. Data. And this is the scenario where their anxiety levels were self-reported across 3 levels, one at pre-treatment, then post-treatment and follow-up. So there are 18 people in this sample. So each row represents a case and each variable represents a level. So I went into Analyze General Linear Model Repeated Measures, and you can use factor 1 as the name if you want to. You can also replace that and call it time. You can technically call it anything you want, so that just name it something that you'll recognize. And the number of levels is 3 because we have pre-treatment, post-treatment, and follow-up. Those are 3 levels in the within subjects factor. We add that to the box, we click define, and then we put pre-treatment, post-treatment, follow-up into the within subjects variables box. We can see that they're numbered 1, 2, and 3. Then we go into options, and you want your descriptives and effect size. You don't actually have to click anything else. A homogeneity test is not something we're concerned about. The assumption of sphericity will be tested automatically. Click on continue and click on plots. You'll want to look at the means in a plot and click continue. And that's about all I'm going to show you for now, because that's about as far as I went in the textbook at this point. So I'm going to click OK. And this is what I'm going to get here. You get a table first with the measures, pre-treatment, post-treatment, follow-up, time 1, 2, and 3. Here are the descriptive statistics. Anxiety of 44.94 at pre-treatment, post-treatment 0.2533, and then 24.83. So from memory, these were the amount of times the person experienced anxiety during a given month, I think, or something like that. So the numerical trend is going down, but we don't know if there are any numerical differences that are statistically significant. Here are the standard deviations, and it says sample size 18, 18, 18. Don't think that those are different groups. It's all 18. The sample size is overall 18, and 18 people gave a score for each level. It was the same 18 people. You can ignore the multivariate test table, and here's Motley's test of sphericity. We just have to hope to see, and it doesn't make a really big difference if we don't, but when the assumption of sphericity is satisfied, and it's similar to the homogeneity of variance assumption, but a little more complicated than that. When the assumption is satisfied, the p-value will be greater than 0.05, and the p-value here is 0.292, so we haven't violated the assumption of sphericity, and arguably that's a good thing. Keeps things a little bit simpler. Here's the test of within subjects effects, and because we can assume sphericity for these data, we can look at the first row. So the source is the time, and that's the actual within subjects factor. Error is simply the error term to help us evaluate statistical significance. So we have a F value of 14.59 with 2 degrees of freedom in the numerator and 34 in the denominator. So 2 and 34 degrees of freedom, and an F value of 14.59, which is less than 0.05 for a p-value. Significance 0.001 is what we'd report. So it's statistically significant. We reject the null hypothesis of equal means. We don't know which means are different. We just know that they're not all equal to each other. And the partial eta squared is 0.462, which it says that excluding the covariance across time, which I'll show you in a separate video, the percentage of variance accounted for by the cognitive behavioral therapy, or the time factor, is 46.2%. So that seems quite big because it's nearly half of all the variability in anxiety scores. So 0.462 or 46.2 is partial eta squared. So this really is partial eta squared here. Then we have the test of within subjects contrast. I'm not going to really focus on that very much right now, except to say that SPSS automatically outputs linear and quadratic. And the linear and quadratic effects are both statistically significant. I'll talk about contrast analyses more in another video when it comes to within subjects design. I also talk about the between subjects effects more in another video in this chapter. It's not really very important. The vast majority of the time, most people will be totally uninterested in the between subjects effect. Don't be fooled into thinking that there really is a between subjects factor in these data. There is none. It's really an odd label that SPSS uses for this effect. You can mostly just ignore it. And here is the pattern of the means in the plot. So it doesn't look like the one that I produced in the textbook, but this is how it starts off, and you can do work on it to make it look prettier. So this is the video associated with the repeated measures ANOVA that I do in the textbook first.